Welcome everyone. Today I'm going to talk about large language models. Large language models are artificial intelligence models designed to interpret, create, and manipulate human language at a high level. These models are built with deep learning methods, primarily transformer architectures, which allow them to grasp complex language patterns and correlation found in massive volumes of text data. This AI fundamentally altered how machines interpret and produce human language. The term large in large language models refer to the model's massive amount of adaptable parameters that allow it to process and generate text with high accuracy and contextual intelligence. By analyzing patterns and relationship in the data, these models develop a deep understanding of language, help them to perform various language-related tasks. In this video, we will learn about vital elements of large language models, how they work, their applications and limitation, recommended courses, and deployed examples. Vital elements of large language models. First is scale. Large language models have a large number of parameters, often hundreds of millions to billions, allowing them to capture complex linguistic nuances. Large language models are pre-trained on massive text datasets to develop a broad language understanding. They can be fine-tuned on specific activities to adapt their expertise to particular applications. Large language models can perceive the meaning and context of human language, allowing them to do some kind of activities like language translation, sentiment analysis, question answering, and many more. Large language models can generate logical and appropriate language. They can produce human-like paragraphs, stories, summaries, and even code. Now the question is how large language models work. There are a couple of mechanisms involved like transformer framework. Large language models are based on transformer architecture, which is a type of neural network developed for dealing with data patterns, such as sentences in a language. Transformers are improved NLP by quickly capturing context-specific connections between words. Second is attention mechanism. Attention mechanism is again used by transformer is to determine the significance of various words in a sentence based on their context. The model's attention enables it to focus on relevant words and record long-term dependencies. Third is encoding and decoding. Text is processed in these two stages. First, in encoding, by using these embeddings, input text is turned into numerical data. Now the model uses this numerical data to generate text output. Fourth is bidirectional context. Large language models like BERT take both left and right contextual words in contrast to prior models that only processed text into one direction. Now, bidirectional context helps in-depth understanding and confusion solutions. Lastly, pre-training and fine-tuning. To gain broad language understanding, large language models undergo pre-training on big text datasets. Fine-tuning the model adapts it to specific goals by training it on task-oriented data. Now some of the applications. This could be content creation, language translation, text summarization, chatbots, sentiment analysis, image caption generation. Now, despite of their strength, large language models can produce biased or improper content, and there are ethical issues and misinformation concerns. Well, that need to be addressed, right? Some of the examples of large language models are, one could be ChatGPT, right? With more than 175 billion parameters, GPT-3, that is Generative Pre-trained Transformer 3, is one of the biggest language model. It was created by OpenAI. It has proven capable of carrying out a variety of NLP tasks, including text production, translation, question answering, and many more. Second is a robustly optimized BERT pre-training approach that is called robot. This offers cutting edge performance on a variety of downstream NLP tasks by streamlining the pre-training process. Microsoft created the Turing NLG model, which has 17 billion parameters. It is meant for jobs requiring natural language generation, such as text generation and text completion. Last one is Megatron. NVIDIA created Megatron, a massive model with many parameters. It can be used for many NLP architectures and built to handle training with several billion of parameters. Before concluding the video, I would like to suggest two courses. Introduction to Large Language Models and Introduction to Generative AI by Google Cloud. I provide these two courses link in the description. Do check them out. I would suggest to start with Introduction to Large Language Models because they have covered so many foundational ideas behind it and lot of material to read. From my experience, I would like to highlight few parts. One is they have explained large language models' foundational ideas and their principles. They discovered how large language models are pre-trained on massive datasets to identify complex linguistic nuances. Thirdly, I learned about large language models uses like text production, sentiment analysis, and language translation. I hope you liked the video. Let me know your thought. Thank you.